Is on functions and analyzing graphs of functions. So a function, as you guys know, the formal definition is something you probably don't know, but it's a function f from set A to B is a relation that assigns each element in x from the set A to exactly one element y in the set B. So the way that you typically talk about functions is using the vertical line test, right? So you're like, oh, a function is a graph that passes the vertical line test. Okay, so something that would be a function would be like this first one. So I can draw all the vertical lines through it, and only one point is crossing the, I don't know why I did one here. Only one point is crossing each vertical line. Does that make sense? But something that would not be a function would be something like this because there's more than one point. So for a certain x value, there's more than one y value that goes with it. Okay. So it says decide whether the following equations represent y as a function of x. If you don't know the shape of a function, try to sketch a graph using a t-table. So the first one, I have x squared plus y squared equals 4. All of you, after taking geometry and algebra 2, should know what the shape of this graph is. Do you know what it is?
Circle.
It's not a parabola, it's a circle, because both x and y are squared. So x squared plus y squared equals 4. It is a circle that has a radius of 2 and a center of 0, 0. Do you guys remember that? X minus h squared plus y minus k squared equals r squared. It's all coming back. Oh, that's nice long summer. It's always rough the first week. Okay, so is this a function? Does it pass the vertical line test? It does not. So no, it's not a function. It's a relation. Yeah, kind of weird. All right. Kind of. It's not a conic function. Conic section. All right, so I have x equals y squared. So x equals y squared. Anybody know what this is? Might be a little bit harder for you. You didn't do this in geometry as well, but you did do it in Algebra 2 last year. It's a parabola. What does the parabola look like? Sideways. It is sideways. It's not our normal like y equals x squared. We all know what y equals x squared looks like, right? Y equals x squared looks like this. This is x equals y squared. So if we don't know, we can do a little t-table. We could say, oh, when I plug in 0 for y, I get 0 for x. What happens when I plug in 1 and negative 1 for y? Notice how I'm plugging them in for y, not x. 1 squared is 1, negative 1 squared is 1. Same with 2 and negative 2. I get 4 and 4. And so if you sketch it out, we have 0, 0, 1, 1, 1, negative 1, 4, 2, and 4, negative 2. Oops, I did that way over there. So it looks like that. So this is not a function. It's not a function because when I plug in 1 for x, I could have both 1 and negative 1 for y. So not a function. Okay, the next one, do we know the shape of this? It's a line. Now I could say every single line is a function, but that would actually be a false statement. Not every single line is a function. What are the lines that would not be? Yeah, Nat? Yeah, vertical lines aren't functions, right? They don't pass the vertical line test because there's an infinite number of points that go through that vertical line. Okay, but in this case, these are like the slanty lines. Does the slanty line pass the vertical line test? Yeah. So this is, yes, a function. Okay, and you could sketch out what that one looks like as well. It'd be y equals negative 2x plus 5. So it'd start out at 5, and you'd go down 2, right 1, down 2, right 1 if you wanted. Okay, so the domain convention, this is what some textbooks will call this. So it says, unless information to the contrary is given, the domain of a function f consists of all the x values for which the function is defined. Okay, so for domain, we're always going to look at things that make it bad. So I can't take the square root of what kind of numbers? Negative numbers. Can't take the square root of negative numbers, right? I can take the square root of 0, that's okay, but can't take the square root of negative numbers. Can I have a 0 in the denominator? No, that's bad. Can I take the 4th root of negative numbers? No. Can I take the cube root of negative numbers?
Yes.
Ah, yes. So even roots are bad. So square root, 4th root, 8th root, 6th root. I can't take the square root of negative numbers there. But odd roots are okay. And then I'm going to look for denominators. So you're looking mostly for square roots and denominators. So on number 1, do I have either of those, square roots or denominators? I have a denominator. So I know that my denominator, it can't be equal to 0, right? So what if I set x minus 4 equal to 0? What would x equal? 4. So it can't be that. So sometimes I even put like a can't be, right? If you want to do that, it doesn't matter. Okay, so I know x equals 4 is not allowed. So if I was doing a number line, the only number that I'm not allowed to have is 4. I could have 4.0001. I could have anything on the right of it, and I can have anything on the left of it. So my domain is negative infinity to 4 union 4 to infinity. So I'm going to write it in interval notation. Sometimes interval notation is kind of annoying for a domain. So if I don't say write in interval notation, what's the easiest way to write this domain then? It would just be x is not equal to 4, right? So the easiest way is to say x does not equal to 4, not equal 4. That implies that x can be any real number except for that. Okay. So the next one, this is a little bit tricky. Let's kind of think in our heads what is allowed. So can I take, like if I plug in x equals 0, can I take the square root of 16? Sure. Can I plug in 1? Square root of 15? Yeah. Where does it start to be bad? When you pass 4. So can I plug in like 5? No, because then I have the square root of a negative. Can I plug in 4? Yeah, because I have the square root of 0. That's allowed. 4.1? No. Okay, so anything that's bigger than 4. What about negatives? So can I plug in like negative 1, negative 2? Okay, when does it start to be bad? After negative 4, right? So what we're trying to figure out is where 16 minus x squared, where it's bigger than 0, greater than or equal to 0. Which actually kind of involves critical values. You guys remember doing like testing numbers, critical points. So really the way that we would write this is we do 4 minus x and 4 plus x. And then we'd say, oh, we have critical values of 4 and negative 4. Those are the things that make it equal to 0. So on our number line, we would put in negative 4 and 4, and we would basically test on each side of those numbers, which is what we just did in words, right? We talked through that. So anything bigger than 4, that was bad. So you can put like an X or something there. Anything less than negative 4, that was bad as well. So if I plug in like negative 5, I have 16 minus 25. That's negative. Okay, but anything between negative 4 and 4 was good. It worked. So in here, we're good. Endpoints, we can have 4 and we can have negative 4. We can take the square root of 0. That's totally fine. So our domain then is bracket negative 4 to 4, bracket. So those brackets indicate that we have filled in circles on those. They're included in our domain. Still good so far? All right, so this one has both a square root and a denominator. So we're going to look, since inside the square root, we're going to say that t plus 5 has to be greater than or equal to 0. But can it be equal to 0? No, because it's where? It's in the denominator. So it's a little bit tricky. Like, you can take the square root of 0, but we're not going to say equal to 0. We're just going to say greater than 0, because it can't be equal to 0 because of denominator. Kind of shortcutting that. Does that make sense? So it can't be equal to 0 because of the denominator. So we just want to know where t plus 5 is greater than 0. Well, that's pretty easy. It's where t is greater than negative 5, right? So in interval notation, we put the negative 5 on our number line, and we have an open circle, and we have everything bigger than it. So we have the domain is parentheses negative 5 to infinity. All right, so same idea on the next one. So I have the 4th root of 9x squared minus 4. So I'm going to take my 9x squared minus 4, and I would say, oh, well, that has to be positive. It has to be greater than or equal to 0 under there. So it's a little tricky. Like, a lot of people are tempted to, like, add the 4 over. So look up here. Don't write this, though, because this is bad. So don't write this. Like, I see a lot of people, like, add the 4 over and divide by 9, and then take the square root and do plus or minus. They're like, oh, x is greater than the square root of 4/9, which is 2/3. So x is bigger than 2/3, and x is greater than negative 2/3. Okay, but it's not like that. Okay, so you can do that if you had an equal, but not if you have a greater than or equal to. So really the best way is to factor, yeah.
Why do we have a 0 if it's on the denominator? Like,
that's right. So we should maybe say greater than 0, right? Does that make sense? So let's say it that way. Thank you, Greta. Oh man, I'm still writing greater than or equal to. I'll get you a bonus point. Jacob got one today too. All right. So we have 3x and 3x and 2 and 2. We want plus 2 and minus 2. So it's the difference of two squares. Do you guys remember difference of two squares? So we end up getting negative 2/3 as a critical value, and we get positive 2/3 as a critical value. So all that means is we put them on a number line, and we're testing around those numbers. And this part's pretty easy to do in your head. So if I plug in like a negative, well, let's go with this side first. What happens if I plug in 1? If I plug in a 1, I get 9 times 1, which is 9, minus 4, I get 5. Can I take the 4th root of 5? Sure. It's not negative. We're good. So this side works. The same with this side, because if I try negative 1, isn't this just a 1 then as well? So I have 9 times 1 again, so I still get 5. So negative 1 and 1 both work. But if I try 0, I have 9 times 0, which is 0 minus 4. That's bad. So that didn't work in there. So for this one, it's the ends. And then negative 2/3 and 2/3 make the denominator equal to 0, so we can't include those, so it's open on those ones. So our domain then is negative infinity to negative 2/3 union 2/3 to infinity. Okay, like that. So do we feel pretty good with domain and range, or not range, but domain? All right, so whenever you hear zeros of a function, so the zeros of the function are the places where it's hitting the line y equals 0, basically. They're the x-intercepts of the function. So when I say find the zeros of each function, what I'm saying is set your y value, or f of x, equal to 0. Okay, so I have 3x squared plus x minus 10 is equal to 0. I can try to factor. So I'm going to do 3x and x. My possibilities for 10 could be 10 and 1 or 5 and 2. So think about where I'm putting the 5 and the 2 in. So if I put the 2 first and the 5 last, look at your outer and inner. I have 2x and 15x. Are those ever going to combine to be that middle number, 1x? No. So it's like, okay, the 2 didn't work first, so let's try putting a 5 and a 2. Now will my outer and inner swoops combine to be the middle, positive 1x? Yeah, I can have 5x and 6x. I need a negative with the 5 and a positive with the 6. So I'm going to do a plus in front of the 2 and a minus in front of the 5. So when I set each of those pieces equal to 0, so if I do 3x minus 5 equals 0, and I do x plus 2 equals 0, and I solve, I get 5/3 and negative 2. Those are the zeros of the function. So if I was sketching a rough graph of what this is, so you don't have to draw this, but it would be at 5/3 I'd have a 0, and at negative 2 I'd have a 0. And then do you guys know the shape? Like, what shape is this if I have 3x squared plus x minus 10? see it? Is it upwards or downwards? Upwards, because it's positive. So it would look like this. And then the place where it's crossing the y-axis would be -10. So that would be a little rough sketch of that problem. Okay, that's what we're talking about when we talk about zeros. We're talking about where it's crossing the x-axis. All right, so we don't really need that picture, but, well, maybe I'll leave it. It's fine. We'll leave it. All right, so number 2. So for finding the zeros of this function, so again, I let my f of x equal 0, and I solve it out. So to get rid of the square root, I square both sides. So I get 0 equals 2x minus 5. So I get x equals 5 over 2. So I add the 5 over, I divide by 2. Okay, this function, do you guys know what a square root function looks like? I don't know if we talked about this last year, really. A square root function, like this is the parent function, y equals the square root of x. So it's that kind of shape. It's like half of a parabola on its side. If I had a negative square root, it would be the other half. It would be the bottom part. So what this is saying is 5 over 2 is where my 0 is. It's starting here, and then it's going to have that same shape. So we'll talk a lot about like parent functions in the next couple days. So 5 over 2, though, is the 0. All right, and then this one I'm setting my h of t equal to 0, so I have 3t minus 6 over t plus 5. The t plus 5 is insignificant. It doesn't matter in this problem, because the only way I'm going to get a fraction equaling 0 is if that numerator is equal to 0. So sometimes I tell students it's kind of like we multiply it over to the other side, and it just kind of goes away. Right, so that's gone. We don't worry about it. So we have 0 equals 3t minus 6. Add the 6 and divide by 3. So we get t equals 2. That's the x-intercept there. Okay, still feeling good with this stuff? Awesome. All right, next little bit. So increasing and decreasing. So if you have a function, let me just do a little rough sketch. Okay. Do you think from here to here it is increasing or decreasing? Increasing. As you read it like a book, it goes up. Does that make sense? So it's increasing. Then from here to here, it's decreasing. It's going down. And then it's increasing and decreasing. So let me draw all the increasing ones in like blue or something. So I'm going to have increasing from here to here. And then I'm going to have increasing from here to here, and increasing from here to here. And then it's decreasing between. Okay, so increasing, decreasing. Increasing, decreasing, increasing. I should have done so many. All right, the way that we say it's increasing is we say it's increasing over a certain interval. Intervals are x values. So we say it's increasing from this x value to this x value. We don't talk about the y's, okay? And then a constant function, it says a function is constant if f of x1 is equal to f of x2, for any x1 is less than x2. So what that means is it's just straight across. It's not increasing or decreasing. It's just constant. Okay, so it says on what interval is the function f of x equals x squared increasing? On what interval is it decreasing? So you guys should all know what f of x equals x squared looks like. So it looks like a parabola going through 0, 0. It's decreasing, and then it's increasing. Okay, so it's decreasing on the interval what to what? From what x values? Yeah.
Negative x to 0.
Not negative x, though. Negative infinity, because way over there. I know what you're saying. So negative infinity to 0. And then it's increasing from 0 to infinity. Okay. Now at 0, it's kind of like not increasing or decreasing. It's actually included in both of those intervals. So when I say decreasing, it's actually, by definition, we would do a bracket, because look at our decreasing function. So it says for any x1 which is smaller than x2, f of x1 is greater than f of x2. At negative 0.1, or let's just say negative 1 for simplicity, at negative 1 is that is f of (-1) greater than or equal to f of 0? Yes, it is. So we include 0 in the interval because until we get to 0, it's still considered decreasing. I don't know. You can put a bracket if you want. I'm not going to be picky about it. Technically, there is a bracket for increasing and decreasing. Okay, number 2. So it says graph the function f of x equals x cubed minus 2x plus 5 on a graphing calculator. On what interval is the function increasing? On what interval is it decreasing? Find any zeros and round your solutions to 3 decimal points if needed. So this is a weird graph. So everybody get your calculators out. So we need calculators. Okay, so I'm going to go to y equals. So I have y1, y2, y3, and so on. And I'm going to put x raised to the, raised to the 3 minus 2x plus 5. And I'm going to hit graph. Okay, we know what an x cubed graph looks like. It goes up, it comes down, it goes up, right? Unless it's just the normal x cubed, which kind of tapers off and then goes back up. Okay, so do we see pretty much all of the graph? Yeah, we're good. I mean, it goes off forever in both directions, but we can see that crucial point, which is like in the middle where it's going up and then down and then up, okay? All right, if your window is messed up, so just some of you guys have weird windows, do zoom 6 and it puts it on the standard -10 to 10 window. So -10 to 10 for x values and -10 to 10 for y values. Okay, do we all see the same graph on your calculators? Do you guys see it? So hit the button zoom in the middle right here, zoom, and then just hit the number 6. Or you could go down to zoom standard. So zoom standard means the standard 10 by 10 window. Okay, so if I want to talk about where this graph is increasing, it's increasing until we get to that highest point right there, right? So we need to figure out where that's located. Now remember, it's increasing on an interval. So I don't care what that y value is. I just want to know the x values in the end, okay? So what we're going to do is we're going to find a maximum. So we're going to do second trace. Do you guys see where trace is? It's next to zoom. And this is calculate. So it's under the calculate menu. Anything that you're trying to find on your calculator is usually found here. So we want to find the maximum point. We want to find how high it goes to, and it will give us that point. It will give us the x value and the y value. We're going to use the x value. So I'm going to go down to maximum, number 4. So you can arrow down to 4, or you can just hit the number 4. And it should say left bound, right bound. So what that means is I want to get on the left side of what I want. That's going to be the left. I want to get on the right side of what I want. Okay? So I'm going to arrow over until I'm on the left of that bump. And then I hit enter. And then I get on the right side of that bump. And I hit enter. And then it says guess. Usually guess is not very crucial to your graphing calculator. Like usually we don't use it unless we have lots of maximums really close together. So guess we typically like get kind of where we think it is. But if you just hit enter again from where you were, it's going to give it to you. Okay, once it says maximum, that's when we know we're done because it gives us the maximum. Do you guys see how that says maximum 0.816 something? So -0.816. That's what we're worried about, the x value, because we're saying on an interval. So let's sketch a little rough graph. So we have something like that. And then this was the point -0.816, comma 6.089. Okay, again, we're not really worried about that y value, but I'll write it. And then we want to find that other point, so we want to find the minimum. So again, we do second trace, and we find the minimum. So I'm going to go over. I get on the left side of what I want, I hit enter. I get on the left side, right side of what I want, I hit enter, and then I go to exactly where I think it is and hit enter again. So it says the minimum is 0.816, 3.911. Okay, did you guys get all those numbers? Okay, if you need help, let me know. Okay, so when we talk about increasing, we're going to say it's increasing from negative infinity to negative 0.816. And then it's also increasing from 0.816 to infinity. So it's increasing here and here. And then it's decreasing between negative 0.816 to 0.816. Oops. So remember, these are x values for intervals. Okay, and then the last thing it asks for is the 0 or zeros. So how many times did this cross the axis? It crossed once. So we're going to go back to our calculator and we're going to do second trace again. What button do we think we're going to hit now? Yeah, number 2, which is 0. We're going to find the 0. And this kind of works the same way. We went on the left of what we're trying to find. So, you know, the 0 is somewhere like right here. So if I move the arrow to the left, it will get on the left side of that. So you can be as close as you want to. Notice how this is negative, my y value is negative. I know that I'm below it because of that. So I'm going to hit enter, and then I'm going to go on the right side, hit enter, and then I'm going to guess. So go to whichever one's closer. So we get negative 0.2095. So we'll say, hang on, I did this wrong. Negative 2.9, dang it, 2.095. Is that what it was? Comma 0. Get rid of this line there. Okay, so that's our 0 then. You don't have to write it as a point. You can just write, oops, dang it. So I can just write negative 0.2095. This is 0. Okay, does this make sense? All right, do you guys see how these are intervals? These are not points. Like a lot of people will think when I see negative 0.816, comma 0.816, that's a point. Okay, we're using context clues. It's an interval because I asked for the interval where it was decreasing. Okay, and then relative max is also called local max. Absolute max is called a global max. So on this graph that we just did, oops, where am I? Okay, so on this last one that we just graphed on our calculator, we have what we call local maxes and local mins. Okay, so this right here is what we call a local max. In that general area, it's like the highest point on a hill. That's what a local max is. Do we see that? Okay, this right here is called a local min. In that general area, it's like the smallest point in a little valley. Okay, global max, or we sometimes call absolute max. An absolute max is the highest point on the entire graph. Does this have an absolute max? No, because there is no highest point on the entire graph. It goes up forever and ever and ever. So we would say there's no absolute max. Is there an absolute min? No. What if I told you to only sketch the graph from negative 5 to 15? Would there be an absolute max? Yeah, because the graph would stop at a certain point. Does that make sense? Okay, so in a closed interval, there would have to be an absolute max. All right, so it says use your calculator to find all local max and min of the function x to the fourth minus 2x squared minus 4. What is the absolute max and absolute min if applicable? So let's look at a picture, or our graph, our calculator. So we're going to graph it. Oops. So I'm going to do x to the fourth minus 2x squared minus 4. And I hit graph. Do you guys know the shape? It's kind of like a parabola because it's x to the fourth, but whenever you have a minus x squared with that, it like cuts out a downwards parabola in it. It makes like a W shape. So we can find these two minima. You could zoom in if you need to, but I think we can probably get it from here. So I'm going to do second trace minimum. So I'm going to get on the left side of the first minimum, and then I'm going to get on the right side of it. And this one, since we do have two minimums kind of close together, I'm going to guess and get as close as possible. Okay. Look at my calculator. What does it say? Mine said negative 0.999999995. All right, calculators sometimes lie to you, right? Calculators are only as smart as the number of digits they can carry in their head. So it can't carry a lot of digits in its head. What do we think this is really? Negative 1. Okay, now if it said 98215, we probably not going to be that, right? It's probably going to be 98215. But in this case, it's probably going to be negative 1. And you could plug in negative 1 into your function to see if when you plug it in, do you get negative 5? And you do, right? Does it make sense? You could also go to your table and plug in negative 1. Like when I plug in, oops. Let me make it so I can plug in whatever to the table. Did you guys know you have a t-table on your calculator? It's so exciting. So if you go to table and you put in negative 1, you get negative 5. So that's how you can kind of check to see you have that point. Greta, did you have a question?
I was going to ask, is this like local or absolute?
This is, what do we think? Do we think it's a local or an absolute looking at the graph? Probably local and absolute. We'd probably call it both, right? So that point was negative 1 comma negative 5. This point over here, what do you guys think it probably is? It's probably positive 1 comma positive 5. But let's say we go ahead and do it again. So we find the minimum. And we go over here. This is what we call an even function. An even function means when you plug in the opposite x value. So if I plug in 1 and also negative 1, I get the same output. So negative 1 comma negative 5. Or positive 1 comma negative 5, I mean. And then what do we think the maximum is? Probably 0 comma negative 4, because see when I plug in a 0, I get negative 4. But let's check. So if I find the maximum, and I get on the left side, and the right side, and hit enter. Yep. Ooh, look at this. Look at my calculator. 7.6837e negative 7. What does that mean? Yeah, it's like 0.00000. It's in scientific notation, right? It's saying times 10 to the negative 7th. The calculator will do that a lot, where people are like, wait, I thought it was supposed to be at 0. That is a 0. It's just your calculator is rounding. It's doing like an error somewhere. It can only handle a certain number of digits, right? So it's 0 comma negative 4. And if this happens to you guys, if you're getting a lot of things where you're like, these don't seem very right, usually if you just kind of zoom in on your graph and try it again, it will work much better. So what I could do is you could do zoom, and you could zoom in, and you could kind of pick the area you want to zoom in on, and then hit enter, and then you could do it again, and it would give you a much more precise answer. Okay? You could also do something, so if I go back to zoom 6, let's try this. There's something that I love. It's called Z-box. Okay, so use your calculator, so hit graph. And we're going to do zoom Z-box. And basically we can create a big box around what we want to zoom in on. So let's say we wanted only the zeros. So I wanted to get the zeros in there, but I also wanted to get the maximums and minimums. I would start the corner of my box up here. So hit Z-box, so zoom, and then whatever Z-box is. Hit enter once you get to one of the corners. And then you're going to go over and down until you get the full box that you want. So I'm not hitting enter until I get all the way to the end of the box shape. So let's say I wanted it like that. So see how that's kind of putting in all the things that I could possibly want on this graph? The zeros, the maximum, and the minimums, they're all in there. And then once I get to that other corner that I want, I hit enter again, and it zooms in only on that location. I love zoom box. That's like one of my favorites. You with me, Ben? Did I lose you?
I'm still figuring out how to do maximum.
Okay, so maximum, so you do second trace. You do option number 4 for maximum. And our maximum's like right here, right? So we want on the left side of it, and we're going to hit enter. So arrow over to the left, hit enter. Arrow over to the right when it says right bound, hit enter. And then guess, just go where you think it is and hit enter again. And then it will give it to you. So this one still gave me a rounded, yeah?
No matter what I do on my calculator, it's giving me an error message when I enter something, and it's saying I have invalid dimensions. How do I fix that?
Oh, okay. So if you guys ever get this error message that says invalid dimensions, usually that means someone has used your calculator for AP stats type stuff. So if you go to the main screen, like y equals, do you see how your plot 1 is highlighted? Like yours probably looks like this, right? So if I hit enter now, it's going to tell me invalid dimension, like if I hit graph. So what you want to do is deselect that. So you want to go to your y equals, and you want to take that plot one and hit enter, and then it goes away. So then you can hit graph. It'll work. All right, so let's write all these out. So local max. Okay, how high did it go? Or how low did it go, I guess? How high? It was at -4, right? So for maximums and minimums, we use the y value. So I'm going to say my local max is -4, and it happened at an x value of 0. So we want to use the y values for local maxes. My local min is -5, and it happened at what two x values? 1 and -1, exactly. Were any of these absolute? The minimums were, so I'm going to write absolute / local. So it's both absolute and local. And then what about the local or the absolute absolute max? There's no absolute max because it goes up really, really high. Okay, but if I had a closed interval, there would be. All right, almost done here. Okay, so a continuous function. So a function is called continuous if you can draw the function without lifting your pencil. So something that would not be continuous would be something like 1 over x squared. This is not continuous. A continuous function is something where I never had to lift my pencil to draw it. Okay, so this is continuous. Okay, even and odd. So an even function is something like y equals x squared. This would be even. Because if I plug in like 3, I get 9. If I plug in -3, I also get the same number, 9. That's what an even function is. For every x value you plug in, if you plug in the opposite x value, you get the exact same y values. So we say it's symmetric across the x-axis. Oh, y-axis, I mean. Okay, and then an odd function, the most basic odd function that we have is y equals x cubed. So if I plug in like 2, I get 8. What happens if I plug in -2? Do I also get 8? I get the opposite. I get -8, right? That's what an odd function is. So whatever number you plug in for x, if you plug in its opposite version, you get opposite numbers out. So if I plug in 7 and I get 343, when I plug in -7, I get -343. Okay, and this is what we call symmetric around the origin or about the origin. Okay, so here's the weird thing. So you guys can take your notebook. Okay, everybody look up here. Here's what symmetric around the origin means. It means if I take this and I rotate it 180 degrees, I get exactly the same graph. That's what that means. So take your page, and if you rotate it around 180 degrees, do you get the same graph? If you do, then it's odd. Some things are neither even or odd, though. Like this one over here, this is neither. Did you like me turning it around? Was that so exciting for you? Like that. Same graph.
Like the 8 is the same.
I know. Well, my 8 isn't attached there. I should group them. Yeah.
So in order to get an even, does it have to have a 0, 0 of 0, 0? Like, does it have to start at the
Nope,
origin?
it does not.
Okay.
So I could have. So Greta asked a good question. She said, does it have to start at 0, 0 to be even? Nope, this would be an even function because I can fold it across the axis.
But it has to be on the
It's the same thing. Yes, it has to be on that axis. Yep. All right. So we'll do more with that in a little bit. So go ahead and start your homework. It won't be due until Monday, but you want to start the homework that I gave you.